Hello friends, how are you? Hope you are doing well. In this video we will solve this problem. Okay, so you got these addresses, memory addresses and contents, and see it said that the initial value of our program counter will be A4, right? So our program counter will hold these addresses, this address. Okay, so let's go to a question. So it said, what is in register 0 the first time the instruction at address AA is executed? So that means the instruction at address A, that means how to say, A will be, the instruction at address A will be B1 B0. So after running this instruction, we just need to say, we just need to answer that what is the value of register 0. That's it. Okay, so let's go here. So see, I make those things compact here. So A4 here is 2000, that means A4 and A5 both are here, right? And these are the values. This is the value for A4 and this 00 is for A5. And I think you know that. If you don't know why I'm doing this and how we are doing this, you can watch the previous videos. Actually, you should watch the previous videos if you want to understand what's going on here. Okay, so let's put our program, make the value of our program counter A4. Okay, so our program counter starts with A4. Okay, so if we start running our program, so it will first go to memory address A4 and load this instruction into instruction register. Okay, right, let me remove it. Let me remove it from here. Right, everything is moving. Why? Delete it. Okay, so first the value of our program counter is A4, so we loaded the instruction from A4, and this is the instruction. We load it in instruction register and change the program counter to A6 immediately before executing this, decoding and executing this instruction. Okay, since we changed the program counter, now let's decode and execute. So what does this instruction means? So let's go to our how to say, this thing, this description, machine language description. So see, the OP code is 2 and these are the operands. The last 3 digit is operand and the first digit is OP code, and it said load the register R with the bit pattern XY. That means we need to load the register 0 with bit pattern 00. As a result, the value of register 0 is now 00, and you can see that I'm not putting the registers, showing the registers here, because I'm already just showing those things here. I'm not, I don't want to waste time just doing this simple thing here. Okay, so we executed the first instruction. So now the value of register 0 is 00, and since we executed this, let's go to program counter again, and it's A6 here. So go to A6 and load this instruction here in instruction register. Okay, so what this instruction does, it's same. See, the OP code is same as before, is 2. So load the register 0 with the value or bit pattern 03. Okay, so it's register 1, right? So load the register 1 with bit pattern 03. So now the value of register 1 is 03 after executing this instruction, right? But one thing, I made a mistake here. See, before executing this instruction, we must change our program counter before executing. We must remember these things. So it's S8 now, right? So now we changed our program counter and now we can execute this. So after executing this, we got the value of register 1 is now 03. Okay, so it's done. So next, go to our program counter again. Now it's A8. Go to 8 and now load this instruction here. The OP code is again same, but the operands are different. So it said load the register 2 with bit pattern 0 1. Okay, so as a result, but again, before executing, please remember to change the program counter. Don't do like me. Anyway, so now we need to load the register 2 with bit pattern 0 1. So see, we loaded the register 2 with 0 1. Okay, so then again go to program counter. Now it's AA. Go to A, take the instruction, load the instruction into instruction register and change our program counter to AC. AC, and now we need to execute this. Okay, execute this. So what does this opcode B means? So if you go here, opcode B, it looks long, but anyway, I'm making it short for you. So it just compares the value of register 0 with the value of register 1, and if the value of register 0 and value of register 1 is same, it will change the program counter. This instruction will change the value of program counter to B0. Okay, but fortunately or unfortunately or whatever but in that case, if we compare the value of register 0 is 0 0 and the value of register 1 is 0 3, so they are not same. So if they are not same, so do nothing. Okay, so do nothing, that means continue. Doing nothing means, we won't change the program counter, so it will just continue with the flow. Okay, so yeah, so we continue. So this instruction didn't change the program counter. So let's go to our program counter again, and we see AC here. So let's go to AC and load the instruction here. Okay, so we loaded the instruction, change the program counter to AE, and now we need to decode and execute this. And what this means, opcode 5 means, wait, go here. So we need to add the bit pattern in register S and T as though they were 2's complement. Okay, if you know about 2's complement, that's good, and if you don't know, don't worry for now. Okay, just add these values as just general addition. Okay, so what we will do, we will add the value of register 0 and register 2, and after adding the value, we will just move the value to register 0. Okay, so see what it did. It did like register 0 equal register 0 plus register 2. So I hope you can understand what's going on. So the value of register 0 is 0 0 and the value of register 2 is 0 1. As a result, now the value of register 0 is 0 1, right? So I think we went too far, and because for question A, it just said first time we run this at the instruction at memory address A, what will be the value for register 0. So see, we ran it before here, so it did continue, but the question just asked for the value of register 0 after we ran this instruction for the first time. So see, the value of register 0 is 0 0. So the answer for question A is 0 0. Okay, or register 0 equal 0 0. There's the answer for question A. But okay, so question A is gone. So question 2, it says the second time what is in register 0 the second time the instruction at A is executed. So the instruction as A will execute again, and you will see how it will execute again now. Okay, so after executing it twice, we just need to answer the value of register 0 again. This is what the question B asked. That's it. So just keep going along with me. Okay, I hope you will understand. Anyway, so now we are here. So we added added the values of register 0 and register 2 and keep the value into register 0. So now the value of register 0 is 01, right? Then we so then we went here and we see program counter is AE, so we need to load the value of program of memory address AE into our instruction register, right? This one. And now we immediately need to change the program counter again, so it's BO, right? BO. And now we need to execute this instruction, and if we execute this instruction, you will find that the opcode, since the opcode B, so this instruction, what it does, if we again go to opcode B, it compares and jumps and continues anyway. Okay, you can read this, so that I'm explaining you here again. So again, it will now compare the value of register 0 with the value of register 0, and as a result, since the value of register 0 is obviously equals to register 0, right? So the value of our program counter will get changed to A, and this is what is called a jump or jumping, okay, or jump to A in that case. So it changes the value of our program counter. So before it was BO, now it will change the value of our program counter. Now it is A again. Okay, so we executed this instruction, and now go to program counter. Now we can see AA here, double A. So we need to go to A, memory address A again. Okay, so now if you go here again, what it does, it just again it checks. See, if you go here, so again, okay, do everything. So we loaded the value of A here, right, and change our program counter to AC, right? So see, and now we need to decode and execute this, and this is this is just the same as before. So we need to compare the value of register 0 and register 1, and if we see the value of register 0 and 1, we will change the program counter to BO, and if it is not, just keep the general flow. That's it. That means we won't change the program counter. Okay, so let's see. So now we found that the value of register 0 is 01, right, and value of register 1 is 3, right? So yet it is not equal to, it's not equal. So we will continue the general flow. So again, go to AC. We are in program counter and we found AC here, and again go to BO. Again go to AC, and we go again in program counter we can see AC here. So go to AC, and we found this instruction here, and load this instruction again. And one thing I should note it down here. Let's see, from here we once again went to okay, let me show you. We once again went to AA, right? So first time we did that, and now we are again going here to A, and this is second time, right? The second time we entered A, and we executed the value of AA. So yeah, we executed the instruction at memory address A, and after executing that, and after executing that, what was insane question. See, it said what is in register 0. Second time the instruction at address AA is executed. So see, we just executed the instruction at A, right, second times. So So now what is the value of register 0? This is the question. This was the question. So we found the value of register 0 is now 0 1, right? Before first time it was 0 0, but we went here and we added the values, and now the value of register 0 got changed to 0 1. And then again from here we compared, and since it's not since it's equal all the time, right? Register 0 and the value of register 0 is same all the time. So we jump to A, and then we executed A again, and so we executed A twice, right? So now just we need to tell the value of register 0, and which is 0 1. I hope you got it. So this is the answer for question B. B 0 1. This is the answer for question B. Sorry for I'm just going one step forward every time. Anyway, because I forgot the question. So see, after executing this again, then next the value of program counter is AC, right? So we went to AC and loaded the value or the instruction here, and we now again need to change it to AE, right? After AC there is A, right? And now you need to execute this. And since before we found that the value of register 0 is 0 1, and now we are again doing the same thing. So now we know the value of register 0 is 0 1, and the value of register 2 is 1 all the time, right? So now since we are again doing, so okay, this is the value of register 0, and this is the value of register 2, right? Yeah. As a result, now the value of register 0 is 0 2. Okay, and again we came here and we executed this line, right? We executed this line. So this instruction. So now again go to program counter, and we found AE here. So again go to AE, okay, and load the instruction from this address, and change the A again to change the program counter. Now it is BU, right? So now you need to execute this instruction. So if we execute this instruction, we will again found that it's just comparing the register 0 with the value of register 0. So it's always it will be same, it will be equal, right? So we need to change, this instruction will change the program counter again to A. That's it, it changed the program counter. So this instruction got executed. As a result, now we see the value of program counter is A. So again go to A. So I should pick another arrow here because we are going there twice, right? This time before, and now we are doing it twice. So again we are going to A, right? So this is first we went to A, then second time we also again went to A, which is described with this arrow, and this is third time we are going to A again, right? So now we loaded and now we see that the value of program counter is A. So again load the value of A here in instruction register, okay, in instruction register, and immediately change the value of the program counter to AC. And now just decode and execute this instruction. So what this instruction does, this instruction again checks the value of register 0 and register 1, and if they are equal, the program counter will get changed to BO. But we found that now the value of register 0 is the value of register 1 is 0 2, and the value of register 0 here, wait, but we can see here that the value of register 0 is now 02, right? And the value of register 1 is 03. So still they are not equal, so we are not jumping anywhere, so it is doing nothing, just continuing. Okay, so let's again, so this instruction got executed and it did nothing. So again go to our program counter, we see AC here. So go to AC memory address and load this instruction again and change the program counter AC to AE, right? So now we need to execute this, decode and execute this, and we know that what it did before. So it just added the values of register 0 and register 2 and keep the value into register 0, right? So as a result, say the value of register 0 was before 02, but now it will get changed to, okay, so the value of register 0 is 02, right? And the value of register 2 is 01. So now the value of register 0 is 03, right? So we executed this instruction again, and now again go to our program counter and we see AE here. So go to AE again and load the instruction we found in AE. So put it here. So after that, after loading the instruction, don't forget to change the program counter value. So now it's B0, right? Now it's B0. So now we need to just decode and execute this, and what this means, it just compares register 0 with the value of, it just compares the value of register 0 with the value of register 0, which is obviously always equal. So it will change the program counter again to 0 to A. Okay, so it changed the program counter to A again. So this instruction got executed, and now we are again going to program counter. Okay, a program counter, and we found AA here. So again we are going to A. So this is fourth time we are going to A. Wait, this is fourth time we are going to A. Okay, and you can see 3 arrow here because for the first time we didn't there is no arrow for the first time. Okay, so now we again went to A and we found the value of A is this one, right? The instruction. So load it here. So load the value here, B1 B0, and immediately change the value of register and a program counter to AC, right? And now we need to decode and execute. What this does, this again just do the same thing. It compares the value of register 0 with the value of register 1. Now we can see the value of register 0 is 00, right? And the value of register 1 is also 03. So actually now this time this value of register 0 and value of register 1 is equal. So change the program counter to B0. Okay, so we are changing the program counter to B0. Okay, we changed the program counter to B0. So now we executed this instruction and the value of program counter get changed to B0. And now again we have to go to program counter since we finished executing this instruction. So go to program counter, the value it holds is B0. Let's go to B0 now and load the instruction at B0 we found. Okay, which is C000, and change the program counter to B2, right? Okay, change the program counter to B2, even though there is no B2, but it will get changed. But even for this question we don't need to think about this because it didn't ask that what will be the value of your program counter or your instruction register. but for learning purpose I am doing like this. Okay, so from BO again our program counter we loaded the instruction of BO, and now we change the program counter again. Okay, and now we need to execute this instruction, and we know if we execute this instruction C000, it means halt execution. This actually will stop our program. Okay, so we now run this, and we found that our program got stopped. Okay, so see, what was the last question? The last question was how many times this is the instruction at address AA executed before the machine halts. So before our program got stopped, how many times the instruction at memory address A executed? And we found that it ran 4 times, right? We ran it 4 times. We have to go once, and then again we went there twice, and again we went there 3 times, and again we went there 4 times. Okay, and in for when we went there for 4 times, actually it didn't continue, then it jumped to BO, right? Jump to BO. That means last time when we ran this command, it changed the value of our program counter to B0. Okay, change the value of our program counter to B0, and then we loaded the value then we loaded the value of B0 into our instruction register, and again changed the program counter to B2, and then executed this, and as a result our program got stopped. So we found that we ran this instruction at memory address A 4 times. So that's the answer. So for C, 4 times, and this is what it asked for. That's it. That's ABC. I hope you understand this. And actually for doing this we don't need to do this from the next time, I guess, because now you understand these things really well, how things are going on. So later we can just directly just do these things. Okay, so hope you understand, and if you have any questions you can ask me in the comment section. And if you find that I have done any mistakes, and if you are confused about it, you can ask me about that. Okay, so bye for now.